Delia from Cyberstorm, and I'm here with our chief scientist, Viorel, and we are going to talk a little bit about the AI landscape today and also about neuromorphic computing. So, hello Viorel.
Hello.
I'm going to start with a question, and I want to know what inspired you pursuing neuromorphic computing, and what keeps you passionate about it?
So, it's a long story. What I think is that humanity today is nowadays it's at a threshold. So we are reaching some limits of our current technologies, as this was happening in history a few times, and humanity basically has two ways to go. One is to develop an entire class of new technologies which will allow us to overcome these thresholds, or to fall back to enter in a profound crisis. And I think that today we can't afford bronze collapse style crisis, because that will mean eradicate life on Earth. So we have to develop new technologies in order to overcome these thresholds, which are coming from limitation of our current energy resources, fossil fuels, of our pollution, not only carbon dioxide but also plastics, forever chemicals and so on. So we need an entire class of new technologies which will allow us to develop nuclear fusion, to develop entire class of new materials which will not pollute, and finally, as Asimov was saying, to allow us to leave Earth and start colonizing the space. For all these things, I think that human mind is not enough. I mean, we have tried in the last decades to develop, to overcome these problems, but it's clear that the solutions are not good enough. And I think that the key for developing this entire class of new technologies will be to have artificial intelligence as a tool to help us in mastering all these technologies. Now, the artificial intelligence was starting to bring some very good results in the last years, and we are now entering in this new age. But I think it has a fundamental problem, that basically what we are trying to do is to use our current computers, which were developed for doing mathematics basically. So they are using so-called von Neumann architecture, where you have memory and processing separated. And basically what we are doing today is try to use our computers in order to simulate how our brains is working. But this is totally inefficient from an energetical point of view. You need a huge calculus power, and that means huge energy consumption. So I think on this part, in very short time, probably a few years, the development will be blocked, because we will need more and more and more energy resources.
So you're saying we're reaching a point where we have to, where we need a paradigm shift.
Artificial intelligence, as it is now, with using traditional computers and huge data centers and so on, will reach some limits in development. Already people are speaking about nuclear powers, gigawatts nuclear powers to be installed near data centers and so on. So it's clear that if we look further on in 10 years or so, this part will stop at one moment. So we need to find another way. And the natural way, I mean, is to try to understand how our brain is working, and to use another type of computers which will be more suitable for the tasks which our brain is doing. That means, if we look at our computers, they are very good in doing mathematical calculus, but they are very bad in doing, for instance, pattern recognitions. human brain is not so good in doing mathematical calculus, as we know, but it's extraordinarily good in doing pattern recognition. And this is because its internal structure is totally different than the computers which we have today. So we are using basically not separated memory and processing units. We are doing in memory computing. So we use the memory for doing also computing.
So this is what we are doing at Cyberzone. It's Neuromorphic Computing.
We are working toward doing this. So what we are trying to do here is to develop a new kind of processor, which is a neuromorphic one. It's called that. It's inspired by the way in which our brain is working, using basically the memory also for processing, and which should be much more suitable in terms of power and energy consumption for doing pattern recognitions and this development of artificial intelligence, which is more closely to the human way of solving things. So the mathematical calculus, what the current computers are doing, of course, will be necessary, and they will work together. But we need also this part of pattern recognition, which should be done in a neuromorphic way, let's say, to be much more efficient from an energetical point of view and to allow us to do real artificial intelligence and to be possible to evolve it, to let the development of a field possible to go on.
So do you find, you also said that the inspiration is from human brain, how the human brain working, but nature also, nature has a different way of working. Can you give me an example from nature that we could apply in our neuromorphic computing technology?
Yeah, basically the idea of using such kind, I mean, the neuromorphic processor is built exactly, trying to imit, it's inspired by the way in which our brain is organized. So our brain has some tens of billions of neurons which are connected in between by synapses. And the learning means basically establishing some connections between these neurons. And when we have learned a pattern, let's say something, we have established these connections, and when we see that again, we just visual signal which goes to nerves and so on is just passing through that network, and we recognize that pattern. So it's not doing any mathematical calculus. It's just a configuration of tens of billions of connections between our neurons, which recognize that pattern. And exactly in this way, we are trying to develop our processor. So to have such a hardware-based neural network, which is built with current technologies, but which works in a very similar way to our brain. So it's not doing any calculus. We just plan to send a signal to it, and to be possible to recognize the pattern which was trained for to recognize. So we'll be indeed incredibly efficient by comparison with current methods of doing calculus. Because what our traditional computers are doing, what now artificial intelligence is doing, is basically trying to do a lot of calculus in order to establish these connections between artificial neurons, let's say, and you have to do that not only for training, for learning a pattern, but also for recognizing that. You need again to do, and now if we try to think about let's say artificial intelligence which will have capabilities more closely matching the human mind, the amount of energy and calculus power is really truly enormous. So in this way will be not possible to go on. But if we develop such hardware-based artificial networks, which are built in a similar way and function in a similar way to our brain, that means to have some configuration which we learn and we just send some pattern to that and we recognize it. I think, yeah, this is the way in which the artificial intelligence will evolve. And I think also we have to look on the nature, because you asked me about the nature. You see, it's a reason for which the life on Earth has, let's say, evolved to have individual brains on each organism. Why people have not only one brain, a central brain, and is not feasible. Yeah, so it's much more feasible to have individual, let's edge computing, to have individual brains on each organism. It's much more efficient to do that.
So, do you think that we talked about a little bit earlier about the AI landscape today, and do you think that apart from neuromorphic computing, quantum computing might be also an option?
It's hard to say. Probably yes, but for the moment, it's the problem with quantum computing. It's somewhat similar with current challenges in artificial intelligence. That means huge data center, and where in quantum computing you need the devices and are still expensive, huge ones, and so on. So until we find a way to do
surpass this,
yeah, to have something like what we are trying to do for artificial neural networks, to do also for quantum computers, also to bring it in a small dimension, in a small things. Yeah, I think it will take a while, but for sure it's something which, yeah, will have an impact.
How do you think about what NVIDIA said yesterday at its conference? They are scaling up, and it's a feasible way of doing things?
For a certain amount of time, yes, of course. I mean, it's still possible, but the problem is on a time scale when you look. So if you speak about next year or 2 years or so, probably it's possible. If we speak about next 10, 15 years, I don't know, because again, if we start to build, if we need to build gigawatts of nuclear powers and so on, close to each data center, and
it's not even a sustainable way.
Yeah, and again, we have to look in the future that these models will need always more power. So at one moment
it will be.
be.
You mentioned earlier Asimov. Can you tell me what's your favorite character from Asimov?
It's really hard to say. I even can't say that I have a special character. I think that he was a very clever
writer.
Yeah, and he was able to see
the future.
Yeah, the problems which will appear in the future. I think we can learn from, for instance, it was remained in my mind his saying, or his conclusion, that if humanity will not be able to leave Earth and to go into space, it will die.
So you agree a little bit with Musk, right?
No, I mean, you see, it's a characteristic of all the time. I mean, every time when humanity reaches certain threshold in development, a lot of people who are looking into that are arriving at similar conclusions. So it's logical that all the people who are looking we'll arrive at the conclusion that indeed we need artificial intelligence, we need to develop nuclear fusion, we need to travel in space, we need to solve materials and so on problems. And it's clear, it's the same. Of course, yeah, with differences in approaches and every one with, let's say, with his background understands more or less from different things, but more or less all the people looking to the same problem will find similar solutions on a let's say in a statistical sense.
So I have one more question. Do you see in a few years, I don't know to mention how many, but do you see having near your desk, I don't know, an AI companion?
Yeah, I think we are not very far away of that. If you look already in Japan, for instance, you can already find in some restaurants waitress.
Robots.
Yeah, robots. So it's only a question of exactly what I'm saying, of ability to install, to develop artificial intelligence and to install it, if possible, on individual devices, on individual robots and so on. But it's only a question of when, not of if.
Okay, right. Thank you.
Welcome.